me go ahead and start the recording. You should be able to see my screen right now. You should be looking at designing a data warehouse from the ground up. You see that okay, Liz?
Yes, you're good.
Okay, great. I'm going to go ahead and we'll get started here. Okay, so welcome everybody. I'm very happy that you guys are joining us here for this session. This session is designing a data warehouse from the ground up. Myself, Dustin Ryan. I'm joined here by Mitchell Pearson. We're two business intelligence consultants here at Pragmatic Works, and so we're going to be taking you through designing a data warehouse from the ground up, which includes the steps that we're going to use, some things to consider, and then we're also going to specifically point out some things regarding an analysis services, some considerations that you just want to keep in the back of your head when you're designing your data warehouse for analysis services. Now, if you're not going to be using analysis services for your data warehouse, that's okay. You're still in the right place. We're just going to point out some extra things along the way for those of you in the audience that will be looking to leverage the reporting strengths of analysis services. Okay.
All right. So my co-presenter today is SQLDusty.com or Dustin SQL. Or Dustin Ryan, there we go. He's been at Pragmatic Works for 8 years now. Now, what you might not know is he spent the first 6.5 years as the janitor. But fortunately for him, he's learned a lot in the last 1.5 years, and he is a BI consultant here at Pragmatic Works. He's also a trainer. He teaches our SSAS Masters class, our MDX class. He's a wealth of knowledge. If you go to his blog, you'll see he has over 100 blogs on just those two topics. He is an author, a blogger, and a speaker. He's written 2 books. You'll see them on your screen here. And he is also a trainer of miniature ponies. Right. I can't make this stuff up.
They're so cute. They're so precious. And this here to my left here is Mitchell Pearson. He's also a BI consultant and trainer at Pragmatic Works. He teaches the Intro to SSIS class. He also teaches the SSIS Masters class. So he knows a lot more about me than SSIS. Great resource there. So if you have any questions about SSIS, you definitely need to look up Mitch. He's a blogger, speaker, and he's really has this, very uncomfortable, unnatural passion about model trains. He's got costumes and everything, so I don't want to go too much detail into it, but throw that out there. And you can find his blog, mitchellsql.wordpress.com. All right, so we're going to get started with talking about, before we get into designing a data warehouse, why do we want a data warehouse? So Mitch, can you think of any good reasons why we might want a data warehouse?
Actually, I'll give you a little story.
Ooh, I like stories.
I like stories too. Once upon a time, there was a little bank. And this bank wanted to build these really awesome reports, but unfortunately they...
Hey, you guys, can you hear me? You just lost sound. Guys. Hey,
Liz, it says we're having some audio.
Yeah.
Can you hear us okay?
Yep, there you go.
All right, I'm not sure what the issue is.
Excellent. So we were telling a little story. I'll start over from the beginning here. Once upon a time, there was a little bank, and this bank wanted to have these awesome reports for analysis, but unfortunately they didn't have a data warehouse. And this is a true story. We won't name the bank. And this bank built these reports off of their transactional system. And unfortunately, when they built these reports off of their transactional system crashed, and it took down all of the ATMs for the bank. The end.
Okay, so what you're telling me is that somebody went home early that day.
Permanently.
Permanently.
Yes.
Okay. So that is one really good reason why a data warehouse is something that you want, right? For reporting, right? Historical reporting. There's certain reports that you definitely don't want to be running off of your data warehouse. Now, so that's a kind of a scary story, but those kinds of things happen, and so that's one of the really good reasons why we want to consider using a data warehouse. Now, when we're talking about data really boils down to 2 different types. You have data that supports the execution of the business, and then you have data that supports the analysis of the business. So when we're talking about data that supports the execution of the business, it can be a retail business, it can be a banking, it can be transportation, energy, manufacturing, it can be any type of business, and we have data that supports the business. So somebody is buying products, somebody is logging inventory, somebody's doing something that helps the business run, helps the business make money. So that's the execution side of the business. Then we have the analysis of the business. How many cheese balls did we sell last quarter? What are the account balances that we're looking at right now? How much freight did we ship, or how much freight are we going to ship? So that's the analysis side of the business. And so that's two of the main differences between the OLTP, or your transactional system, and your data warehouse, your dimensional model, your star schema, whatever you want to call it. That's the analysis side of the business. So huge differences there between the transactional system and the data warehouse. Also, you have, how does the user interact with those two different systems? That's another big difference between the systems. So when you have a transactional system, primarily the interaction is going to be at a very atomic level or a very granular level. Somebody's going to insert a new transaction. A customer walks into a store, they buy a product, they say, give me a cheese ball. We insert a record into the database, into the transactional database, because a new customer has bought another cheese ball. Okay, that's the transactional side. Now with the data warehouse side, the transactions are going to be a lot different, right? We want to be able to upload all of yesterday's transactions, which could be 50 million, 100 million, whatever the number might be. We want to insert all 50 million transactions from yesterday up into the data warehouse, so that way we can begin reporting on it. Now it could also be, we want to read a 50 million record, so I can figure out how many cheese balls did I sell yesterday. So the user interaction is going to be different. Now the method of interaction, or the types of queries that are going to be run, are also going to look a lot different. When we're talking about a transactional system, you're going to have atomic inserts, atomic updates, deletes. We're going to insert one record at a time, update one record at a time, delete one record at a time. And the primary method of interaction with the data warehouse is going to be select. You're going to have inserts, bulk inserts, right? We're going to insert 100 million records at one time from whatever happened yesterday in the business, or we're going to select 100 million records at a time because our users are running queries that they're asking. Show me how many sales I had. Show me how many sales transactions I had yesterday, or how many cheese balls I sold yesterday. Those types of queries. Another difference between your transactional system and your data warehouse is going to be the temporal focus, right? Usually in a transactional system, the temporal focus is going to be what's happening now currently in the business. We're not tracking a lot of history in the business outside of what's necessary just to keep the business running. With the data warehouse, we're going to have what's going on currently, right? And there may be a little bit of latency there. Maybe we're only keeping, maybe there's like a day latency. We update the data warehouse daily, and so it takes a little time for the current data to make its way into the data warehouse. But we also keep history, right? Maybe you want to keep 3, 5, 10 years history, I don't know, whatever your business determines is appropriate. You want to keep that history in your data warehouse as well, so that way we can do analysis over time. So are we selling more cheese balls this year than we sold 3 years ago? Now, also, the difference between the transactional system and the data warehouse is going to be the design optimization, right? Typically with a transactional system, you use a third normal form type of design because we want to be able to optimize lots of inserts happening at one time. So we may have 10,000 purchase orders coming in a given hour, and so we want to be able to insert and update those all at the same time. That's how we'll optimize our transactional system. Now with the data warehouse, we want to optimize for high performance queries, and that's really the main purpose of designing the data warehouse the way that we're going to talk about is we want to be able to get the data out of the data warehouse as fast as humanly possible, so that way our users' queries don't have to run very, very long. This is also important for analysis services processing, and we'll talk about that in a little bit here later. Okay. Now, the 4 steps that we're going to talk about are identifying the business process, identifying the grain, choosing the dimensions, and choosing the measure. So these are kind of the 4 CAN steps that you can use when you start approaching either building a data warehouse from scratch or enhancing a data warehouse. Maybe you want to bring in a new business process into your existing data warehouse. Maybe in your data warehouse you've got retail stuff already and you want to bring in some marketing facts. So you can use these 4 steps to kind of approach enhancing a data warehouse as well. And as we're going through these steps, I want you to think about and remember that the purpose of a dimensional model, a well-designed dimensional model or star schema, is we want it to be simple, right? We want it to be easy to use. We want the ETL to load these tables to be as simple as possible. We want our queries to perform well, and we want this to also perform well with SSAS. So let's start walking through these 4 steps here. And as Mitch and I go through these steps together, One thing we're gonna do is we're actually gonna design a data warehouse together. So we've got this kind of imaginary business, a very successful business model. You've probably heard of this company, Buster Block. They said they sell rentals to VHS movies, very successful in the past, and so that's kind of our imaginary scenario we're going with here. We're going to design a simple star schema for this business. Okay, and so we're going to walk through these 4 steps together, keeping in mind that we're designing a star schema for Buster Block. All right, so remember that. And so we're going to kind of approach it from that standpoint, so that way we can talk about these 4 steps, but you can also kind of see it in practice, and you kind of have a good example of using this in your particular environment. Now, the reason we're going with a retail example here is that we don't want it to be complicated. Everybody understands how retail works. Somebody's buying a product, right? And so we don't want to get lost in the minutia of how the business actually works, or the technology, or from that kind of standpoint. So we want to go with something simple so it's easy to understand, and we can focus on actually learning the concepts here. So we're going to start with identifying the business process.
All right, thank you, Dustin. So identifying the business process is going to be the first step in designing our data warehouse. And the question we want to ask there is, what is a business process? A business process is a natural business activity performed in your organization that is supported by some form of data collection. It's important to focus on the business process as opposed to the business departments, because this will allow us to deliver information across the business in a more consistent manner. Otherwise, we may duplicate data. If you think about having a data warehouse in multiple locations in your business, for example, having a retail data warehouse in marketing and then a retail data warehouse in sales, we may have duplication of data that's not necessary, and we want to have one centralized location for that information.
So what you're really talking about here is having that one source of the truth, right? We want to focus on business process, not business department. What we don't want to happen is to have marketing have their own data warehouse, manufacturing have their own data warehouse, and then everybody showing up to the same meeting saying, well, this is what our profit should be for this past quarter, and everybody's got different numbers. So we're talking about focusing on the business process that may span across business departments.
Exactly. Good job, Dustin. All right, so we must first decide what business process we want to model. There's 2 steps that we want to identify when we're modeling our business process. We want to look at the impact that this business process is going to have in our data warehouse, and we also want to look at the risk that's associated with this business process. So the impact is going to be reports that your business want on a daily basis, very common everyday impact, high availability reports. The risk associated with this business process are going to be things like data availability. Can we have access to the data, or is it going to be difficult to get? Do we have data quality problems? You might want something in your data warehouse, but when you look at the data, it's very unclean, and it's going to take a lot of work to get that cleaned for your data warehouse. The third thing there is you might have very complex business logic that has to be applied to actually get that data warehouse up and running, and it might be difficult to get that information from all the different departments. So we need to assess the impact and the risk, and both of those have to take place as part of choosing the proper business process. All right, and the other thing we want to do is we want to make sure we choose the business process that has the most impact from the beginning. We want to get that low-hanging fruit. So when we start our data warehouse project, chances are we're going to have multiple business processes that we identify. We're going to have more than one. We're not going to have just one process. We're going to see 3 or 4 or 5 different processes that we're interested in. All right, so chances are we're not going to be able to fit all of those business processes into our data warehouse. We're going to have to choose 1 or 2 or 3 or a couple of those, but we won't be able to fit all of them in there.
So how this is where, I mean, what's the best way to decide what is the business process we start with? If we've got people out there that are starting a data warehouse from scratch, how do they pick? What business process do we start with?
That's a great question. So a lot of times what you're going to find out, especially when you're at a client, so chances are the business is already going to be telling you what those high impact items are. If you're working in a BI environment now, then you probably have a user or a group of users that come to you on a regular basis and they say, hey, can you send me that report again that shows me my profit margins by category? Or, hey, can you give me that report that shows me my freight that was delivered today? And what they're really asking me for, what they're really telling me is that these are high-impact business processes that I need a lot of visibility into. So chances are, if you don't have a data warehouse in your environment now, then you're probably going to have users that are already telling you that they need lots of visibility into these specific processes, and they're high impact for the business. So a lot of times the business is already going to have reports they want, that they're asking you for, and it's going to be kind of obvious what you want there. Now you're going to have to do a little bit of additional research to figure out, is this a high risk item or is this low risk? Is the data going to be readily available? Is it going to be dirty data? Are we going to be able to get the business calculations and the business logic that we need? So that's going to have to take place as part of that process. And so that's good. Another thing that we want to consider, Dustin, that we previously touched on is that when we say identify the business process, we're talking about business processes for the company, not for an individual department in the company. And what we mean by that is you might have a retail data warehouse in your marketing department, and the marketing department is going to come to that meeting that Dustin was talking about with their own set of numbers, and then you have another retail data warehouse in your sales department, and they come to that same meeting and they say, well, we've had this much in sales, and marketing says, no, we've had this much in sales, and we have conflicting numbers in our company. So we want to have one centralized data warehouse, one version of the truth for marketing, manufacturing, sales, and retail. We want to have all that in one data warehouse, so that's something that we want to consider there. Another way we might determine our business process is by listening to the questions that our business users are asking us. So a lot of times we're going to hear questions. They're going to say, what are the gross profit margins for our product categories for the previous month? What's our average account balance? What is the average rental quantity? We're talking about Buster Block. So what is our current rental quantity? And those are questions the business is going to ask us, and when they're asking us those questions, if we pay attention and we listen closely, then we're going to know exactly what those business processes are that they're looking for that are going to have high impact immediately, kind of that low-hanging fruit in the company.
Right. So if you have, everybody's got that one user that always comes to them and says, hey, can you give me that report? Hey, I need that report again. Hey, I need that report. You probably all have users like that. The ones that they're coming and asking you for the most are probably the processes that have the most impact on the business, because they're the ones that are going to know what's going to be high impact. So what I hear you saying, Mitch, is we want to look for that low-hanging fruit. We want to look for those business processes that are going to have high impact for the business, either make a lot of money for the business, save the business a lot of money, make the business more efficient, whatever, but it's going to be low risk. We can get the data. We have people who can help us figure out the logic, those kinds of things.
Absolutely, exactly. Yeah.
Okay, so in this case, we've already identified our business process. Our example in this case is Buster Block, right? Our video rental store. And so we're going kind of with a retail business process here for this example. Okay, now the next step here is we want to be able to identify the grain of the fact table. Okay, now this is the most important decision that you will make in your design process. We need to identify what is going to be the grain in our fact table. Now, if you're new to data warehousing, you may not know what a fact table is. A fact table is a table that's going to be at the center of our star schema, and it's the table that contains all of the facts about the business, how successful the business is, how many sales did we have, how much quantity do we move, those types of things. So facts are measurements regarding the success or failure of the business, depending on what type of business process that we could be modeling. Now, when we identify the grain, we want to determine what does one row in the fact table represent. Okay, so if we're working in some type of retail scenario here where we want to identify, what does one row in our sales fact table represent? In the case of Buster Block, it might be a line item in a transaction. So for this business process, we're going to decide, you know what, one row in this fact table represents a line item in a single transaction. So that could be an example in a retail scenario, and that's what we're going to go with for this example. Now, for if you're working in some type of business process where you want to track inventory, maybe you're deciding that, you know what, one row in this fact table represents a record of inventory on a particular day. So every day we go out to our data warehouse, we figure out, or not our data warehouse, our physical warehouse, and we determine, okay, we've got, we've got 500 cheese balls sitting on the shelf, we've got, 1,000 boxes of cereal, or we've got, whatever is in our warehouse, and we want to log that every day into our fact table. So maybe if in an inventory example, one row would represent a record of inventory on a given day. But when you determine what one row represents in your fact table, it's important to go with the most granular level. You want to design your dimensional model to support the most atomic or granular level that you have with your data. Now, when we're talking about atomic, the most atomic level, we're talking about data that cannot be subdivided anymore. We can't break it down anymore. This is as low as the data goes. We can't subdivide this anymore. And the reason we do this is because data that is at the most atomic level can be rolled up, it can be aggregated, it can be sliced, it can be diced, in pretty much any way that the users want. Okay, and this is really good for ad hoc queries, because the bottom line here is that we can't predict how the users are going to query the data warehouse. They might tell us that, look, we want a report that does XYZ or shows XYZ, right? But the moment they realize that, okay, well, we can ask other questions of the data warehouse, or we can ask other questions of the cube, they're going to start firing all kinds of other queries. They're going to connect to the cube with Excel. They're going to slice and dice in ways that you didn't really expect. And so that's one of the reasons that we want to store this level data at the most atomic level. If we decide, you know what, I've worked in situations where a client has said, we really only want the data at the month level. We don't care about it at the day level. You usually still always want to go with a granular level, because eventually they're going to ask you, hey, can we look at this? What happened? We see an anomaly at the month level, right? And so, okay, well, we want to figure out where this happened at. Well, we can't, right? Because we've aggregated our data warehouse up to the month level, so we can't roll it down. And so that's always something to be aware of.
So I got a question for you. How much work would it take to rework that? I mean, if you build your entire data warehouse on a monthly level, or maybe a weekly level or a daily level, and you want to go more granular, how much work would that take?
I mean, if you've designed your whole data warehouse to be at the day level, or at the month level, and then later on down the road, you know what, we want to take this fact table and we want to roll it. We really want to change it to the day level. If you don't have that history somewhere else, you're not going to be able to get it. Okay, so that's a problem for one. But if you can, it's going to be a lot of work, because then you're going to have to rework the fact table. You're going to have to rework dimensions. You're going to have to rework ETL. You're going to have to do a lot of rework there. So that's kind of why I said at the start of this that you want to focus on getting this step right, because if you mess this step up, it's going to cause problems for you later on down the road. Okay, so the bottom line here is we can't predict what queries the users are going to run against our data warehouse, so we want to store it at the most granular level, so that way they can ask any questions they want. All right, so in this particular case, let me bring my virtual machine over here so we can kind of do this together here. All right, so we're going to stub out here a data warehouse design together. And so what was our grain statement? One row represents a line item in a transaction at a Buster Block store. Okay, and so we're going to start here with a new table, and we're going to call this fact sales, because we're going to give it the fact moniker, because this is a table that is going to contain our fact data, those measurements that the business has identified that they can use to tell how much success they're having in the execution of their business. Okay, oops, I already created that one, so we'll call it fact video sales. How about that? Okay. All right, and so when we determine the grain of our fact table, based on that grain, we can determine what kinds of dimensions, which we're going to move into here in a minute. We can determine which kinds of dimensions that are going to be related to this fact. So if we know it's a line item on a transaction in a store, so we know that there's going to be a product related to this, right? Somebody's renting a movie. Maybe they're renting, Gone with the Wind, Dances with the Wolves, Saving Private Ryan. In Mitch's case, All About Miniature Trains. So we know that we're going to have a product dimension that's going to be related to this. We also know that a transaction is going to occur on a given day, right? So we know that there's going to be a date associated with this. And a customer is going to be associated with a transaction, so that we know we're going to have a customer SK there for that. And we're going to discuss what an SK is here in a second. And then also we've got product, we've got date, we've got customer, and what was the other one we said we were going to do? And we've got store, right? This is going to be happening in a store. Okay. And so this fact table here kind of embodies what our grain is, right? This is a transaction that's occurring with a product on a day with a customer at a store. And so based on this, we can do analysis on how many products are we going to sell in a, how many products did we sell in a store last month? How many products do we sell on this day? How many products are bought by our top 10% of customers? How many products are our stores selling by store? So we can do all kinds of different analysis based on this particular grain. So now that we've kind of identified what is going to be the grain of our business process that we're modeling here, now it's time to move into identifying the dimensions. What are the dimensions that are going to be related to this particular grain?
All right, thank you, Dustin. So what is a dimension? A dimension is going to contain descriptive information regarding our data. If I told you that we had $5 million in sales, you're probably going to have some questions about that. You might be excited that we have $5 million in sales, but it's not very descriptive. It doesn't tell you anything about our data. So what we want to do with our dimensions, we want our dimensions to answer those questions that we might have. Questions like, what is the breakdown by product category? Which one of our stores had the highest amount of sales? How much did we sell last month? And we can break that information down by using those dimensions. Now, these are questions that we answer with dimensions, and if you've correctly identified the grain, this step is actually going to be very easy, as Dustin just showed you. The related dimensions will be easily identified. For instance, our grain statement, once again, is going to be one row represents a line item on a transaction in that fact table. All right, so we have product. Dustin's already showed you that one. We're going to have customer, we're going to have date, and we're going to have store. And Dustin's going to go ahead and throw those dimensions up there on our diagram for you. And then we'll start talking about those attributes that are related to that. But we can get that from the grain statement. One row represents a line item on a transaction. We know the transaction had a product that was rented. We know there was a customer involved. We know that it happened on a specific date and at a specific store. So the grain is very important in everything else that we're going to do actually working through this data warehouse. However, if you're going through this and you identify a dimension, if you're looking at your grain statement and you identify a dimension that is not correctly represented in our grain statement, then step 2 in the process, identifying the grain, must be revisited. We have to go back to step 2. So Dustin, this is actually a good little segue here to ask you, do you see any chance that our granularity identified can actually be subdivided further? Because it's pretty low right now.
You know, that's a good question, and it's something that you have to take into consideration as you're going through the design of your data warehouse. So in this particular case, we've determined that one row in our fact table represents a line item on a transaction, right? But if we get into identifying the dimensions, and our business users come to us and say, hey, we want to be able to tie a particular transaction to a special that's going on, a coupon that the customer used, some kind of promotion, whatever might be going on in business, so that way we can analyze a promotion effectiveness. Now, if we do that and say, okay, well, there could be one promotion or more than one promotion associated with a single transaction. So maybe there was a deal going on, rent one movie, get one free kind of thing. But they also had a coupon for a bag of Skittles or something like that. Okay, so you've got a customer using a coupon, and then you've also got the store promotion going on. And so each of those promotions has an effect on that sale. And so we may determine that, you know what, the grain of this fact table isn't really one line item. It's a coupon, one coupon per line item. So we could have multiple coupons associated with a line item. So if that kind of happens where you decide that, you know what, the grain of our fact table is not correct, we've got to go back and revisit this, then it's important that at this stage you go back to step 2, because we've got to get the grain nailed down. This is the most important step, because like I said earlier, if you mess up the grain and you find that out later, it's going to cause a lot of rework. So if you get to identifying the dimensions, or if we get to step 4, identifying the measures, and you determine that, you know what, our grain statement is not completely correct, we need to go back to step 2 and revisit that, so that way we can get that correctly, because this is really going to lay the foundation work for the rest of the data warehouse, and the cube as well. This is going to play an impact on the cube. So if you find out you've done the grain wrong and you're already into the cube part of it, then you've really got a lot of work to do.
All right, good job. Thank you, Dustin. All right, we actually have a couple questions here. A lot of people in the webinar noticed that we did not add the employee dimension, and they're letting us know about that. So if you want to throw that in there, you can. And then also, the next thing that we had a lot of questions on is what is a surrogate key? So I'm coming to that point in just a second.
Man, it's like they're reading your mind.
I know, they're ahead of me here. We're going to talk faster.
Okay.
So in my product dimension, the first thing we're going to do here in this dimension is we're going to add a database key for the table. The database key is an identity key on the column, and this is called a surrogate key. And this is going to help us with modeling the relationships between the dimensions and the fact tables. Now, the reason we don't use the business key is if we use the business key, then we're going to be vulnerable to things like source changes in the transactional system. And that might not mean a whole lot to you right now. And we don't have time to get deep into detail on that. But if something changes in your source system, like a metadata change, the data type of that changes, it's going to affect all the relationships between your dimensions and your fact tables. So we want to insulate ourselves from those kind of changes. And that's what the surrogate key is going to give us. So as we import data out of the transactional system and into our data warehouse, if there are any changes in the sources, that could definitely cause a lot of problems for us. So aside from just insulating ourselves from any of those issues in our source system with our data warehouse, we're also going to create a database key. I'm sorry, we're going to go ahead and create our product key or our product ID on our product dimension as well. And I'll let Dustin kind of catch up here. So the product ID is going to be the business key. We just moved from our surrogate key, which is that primary key in our data warehouse, but that business key that's critical to our business is going to be the product ID. The product ID is going to be how we can essentially go from our data warehouse back to the transactional system, and we can kind of track and trace exactly where that product came from. And we can see exactly what that product is, any of the transactions around that product. So the business key relates back to the transactional system, but that surrogate key does not. That unique identifier in our data warehouse does not relate back to the transactional system. And there's also a couple other reasons why we want to have that surrogate key, other than just insulating ourselves from changes in the source system. One good example is it's going to actually optimize the joins in our fact tables and our dimensions. So now we're going to be joining our fact tables and our dimensions on single integer columns, on these simple integer columns instead of strings or any of those other data types, which is going to simplify our model and improve our join conditions. Surrogate keys are also going to allow us to keep historical information in our dimensions over time. So if you're building a very robust data warehouse and you want to be able to track sales when you were selling a product at $5 and when you were selling a product at $6, and how much did we sell? Did sales increase or did they decrease? We can keep that kind of information in our data warehouse by keeping a history of the price that we sold that item at or that we rented those rentals at. So that's what surrogate keys give us. We can't build a slowly changing dimension that changes over time using business keys. The other reason that we might want to use or not use the business key is that we might have two different departments in our business that have different product IDs for the same product. So you might have marketing that simply calls all baseball bats just baseball bats, but then our manufacturing department might have a product ID like ABC123. So those IDs don't necessarily relate between those two departments, but by creating that surrogate key, now we can have that one consistency in our data warehouse. So those are three other reasons why you might want to have surrogate keys, or why you should absolutely have surrogate keys in your data warehouse. All right, so Dustin is filling out your dimensional model right here on the board here. So in our product, let's see what we have here. We have product ID, that's that business key. We have product name, product type. To keep this a little bit simpler for a 1-hour webinar, we're not putting everything in there, but just imagine what else you could have in your product dimension. You might have product size, you might have the date that you started selling the product, you might have the list price of the product. How much do we sell this product for? These are all things that we can track over time that's related to our product.
Let's have that. That's a good one. List price.
List price, especially for historical, slowly changing dimensions. Something
Right.
you might want to track over time. All right, so you have the sell date, you have the customer. Are we going to put the store in here?
Yep.
The store is
in
next.
there. Yep.
All right. All right. So in the customer dimension, we have our customer first name, customer last name. The address is very important. Where are our rentals coming from? What zip code are we getting our rentals from? And we can break that down. That can be information that we give to our marketing department. That's very important. We might do some other things in customer as well, though, right? We might do gender.
Mm-hmm.
We might want to know if they're married or not. We might want to know their date of birth, so we can kind of get an age of our average customer and the genres that they might be coming in there and renting from us. So that would be very good information to have. All right. And now you've thrown the store in there. So in the store, we're going to have some good information in there as well. We're going to have the store name. We're going to have the store address. We're probably going to have some stuff like maybe the store manager. Now, as you get into a little bit more advanced data warehousing concepts, you might break the store manager out into a separate table. But we want to keep this as close to a star schema as we can. So you can add the store manager in there, absolutely. And Dustin's also going to add the employee dimension. Now, I was actually interested in the date dimension that you added over here, Dustin. You got some, we could add a holiday in there. Holiday information would be pretty interesting.
Yeah, exactly. Now, one thing that I'll mention here with attribute selection is that the best kinds of attributes that you're going to have in your data warehouse are going to be those attributes that are most descriptive, right? So what you don't want to happen is you don't want to have a dimension like store, right? That is just full of IDs, right? So you've got like the store ID, maybe you've got the geography ID, or you've got like all these different types of IDs that are just all these integer values. So the best kinds of attributes are going to be very descriptive types of attributes that the users can look at, and they don't have to ask a lot of questions about that. What you don't want is you don't want your user to have sticky notes all over his monitor because he's trying to figure out, okay, store ID number 12 is the one that I've been watching lately, so I have that written down somewhere. So you want them to be able to look at the attributes and to have a very clear understanding of what the data is, what's included in there, and they don't have to come to you with a lot of questions about asking, what does this mean, right? You want it to be kind of intuitive from that kind of standpoint. Now, I want to point out, now that we've identified our dimensions here based on our grain statement, right? And so we've determined that at a transaction item level, we can basically understand there's a product associated with that, there's a date associated with the sale. An employee, worked with the customer on that sale. It happened in a store, and a customer bought that product, right? So we've been able to identify our dimensions there. And I want to point out a few things to be aware of when regarding SSAS. Okay. You'll notice here that I included a date dimension. This is very important for analysis services. And so you want to make sure that you always include a date dimension in your data warehouse. And some of you out there may be thinking, okay, well that's silly. Yeah, duh, we want a date dimension in our data warehouse. But I have seen data warehouse and I have seen cubes before that didn't have a date dimension. And so it was always just kind of known by the users that, okay, this is just a point in time, right? The date is going to be whatever is the last current date available, which is not exactly all that useful, because if you don't have a date dimension, you can't track things that that aren't included with basic T-SQL functions like company holidays or fiscal calendars, those types of things. So we need a date dimension to track those kinds of attributes. But also in analysis services, if you want to do any types of time calculations like last year, how many cheese balls did we sell last year, or how many movies did we rent last year, or if we want to do any type of year-over-year growth analysis, or if we want to build any trend reports or anything like that, we're going to need a date dimension in analysis services to do that. Now, as I've kind of gone through the dimensional model here, our star schema here, and I've put in the attributes into the tables, I've just kind of used generic data types. And so this is just from a purely exercise standpoint. And so the data types here aren't that important. But in your environment, they are very important. You want to make sure that you use the smallest data types possible, because this is going to play ripple effects into analysis services. So if you don't set your data types up correctly and you just set everything in your data warehouse to a string, we're saying, you know what, everything is varchar 50 and that's what we're going to go with. This is going to negatively affect the performance of SSAS. And the reason for this is because in analysis services, your string data is actually stored in a separate file. And so anytime analysis services has to access a string data, whether it's a customer name, a store name, an address, a month name, anything like that, it has to go to this other file, look up that data, and then return it to the results. So there's going to be a performance impact to your queries and processing of your cubes when you use string data. So it's important to use the smallest data type possible. If you can store something in an integer or a big int, you want to do that, because that's going to improve the performance of your cube. Also, it's important to just kind of remember that a single field non-nullable integer key is the best data type we can use. So if you can do that, do it. But like I said, the best data is going to be the descriptive data, so you don't want to go overboard. You want to strike a balance there. If you can store a customer name and use the customer ID, that's an integer, as the key value for that column, that's something good to do there as well. Also, one thing that you want to keep in mind as you're going through the design of your star schema here is use user-friendly naming conventions. Don't go with, don't expose things like fact video sales to the users. You want to expose it as maybe just video sales in your cube. DIM employee, they're not going to understand that DIM is short for dimension, so you want to expose the objects here in a user-friendly way. And the last thing I'll say about this is about dimension optimization is look for opportunities to build in natural hierarchies into your dimension design. And so we're talking about hierarchies. We're talking about arranging relationships between the data in a natural way, such as you have calendar year at the top, you have month under that, then you have date, right? So you have this kind of natural hierarchy, these natural relationships that exist between the data. Because you can build those kinds of relationships into analysis services, and when you have those attribute hierarchies or user-defined hierarchies correctly built into analysis services, it gives you a performance bonus. So that's something you want to consider as well. All right, so I don't think I'm going to go any farther with this. I think you guys get kind of the point here of what we're doing with the dimensional model here. And so once we've identified the business process as step one, then we've identified the grain, and then based on the grain, we're able to correctly determine the dimensions and the attributes that are going to make those dimensions. It's time to move on to the last step, and that's identify the measures that we want to include in our fact table. Okay, so the measures are going to be, how does the business measure success? Okay, so this is going to be say things like sales amount. What was that line item sale amount? What is the product cost associated with that sale? How many videos were on that line item? Did they rent, a DVD copy of, Dances with Wolves, and then a VHS copy of Dances with Wolves? Whatever the case may be, or did they get, 10 bags of Skittles for their fat little kids? So you're going to have a quantity associated with that too that we probably want to track. Now I'll say the same thing here that I said when we were discussing designing, or when Mitch was discussing designing the dimensions. If we identify a measure that violates our grain, what do we have to do, guys? We got to go back to step two, right? We got to go back to step two because we've identified something in our model that violates our grain. So we got to go back to step two. Let's revisit the grain statement, make sure that we actually have that correct, and then we can come back. We can go back to step three, make sure our dimensions are squared away. That's all correct. And then we can come back to step four where we're going to identify our measures, identify the facts. So in this particular case, let me pull back up my dimensional model here. Now we're ready to get started with the step where we're going to build in the measures into our cube. So we consult with the business, say, hey, what are the measures you guys want to track? What are those high impact, low risk metrics that we want to track here in our cube or in our data warehouse? So they may say, okay, well, we want a sales dollar amount, right? That's important. And I'm just going to put these as int, but you probably do like decimal or something. There's going to be a quantity associated with that, right? And maybe there's also going to be a cost amount, right? And that would be important to track if we wanted to figure out any type of profit or do any profit margin type calculations. Okay. Now, and I'll just go ahead and put those three in, and we'll just stick with that because those are three pretty common measures that you probably have if you have a retail business process modeled in your data warehouse. You probably have those types of measures as well. But you might have other things like a shipping amount or tax amount or whatever the case may be. Now, when you're identifying measures for your star schema, the best measures that you can put in your star schema are going to be measures that are fully aggregatable, or are fully additive. And what I mean by that is measures that can be rolled up, they can be sliced and diced in any way, shape, or form, and the number always makes sense. So, for example, if we roll up our sales for all geographies, I can see what are my sales across all of my geography regions, right? That number makes sense. If I want to see my sales for customers, that number still makes sense. If I want to see my sales by month, I can slice it by month. That number always makes sense, okay, because it's a fully additive, fully aggregatable measure. Those are going to be the best kinds of measures to include in your cube because your user really can't slice that wrong. They can't. They'd have to work pretty hard to mess that up, right? So measures that are fully additive, fully aggregatable, and that are always valid, no matter how they slice and dice it. Those are going to be the best measures to include in your data warehouse or in your cube. Now, you may have a requirement for some measures that are not additive at all. You can't add them up and have them make sense. So an example of something like that would be not profit margin, right? So we can't put profit margin in the table and then have the user add that up because that number would be nonsensical, right? It's not going to make sense to the business or the users if they add up profit margins for all geographies, and they'll end up with some crazy number that won't make any sense, right? So measures that are non-additive, those are measures that are going to be better handled in the data access tool. So it may not be SSAS. You may not be an SSAS shop, right? You may be using some type of other reporting technology like Tableau or something, or maybe you're even doing it in Power BI, or you've got something else, Power Pivot or something else going on there, right? Those types of calculations like profit margin are going to be better handled in the data access tool. And certainly SSAS can handle those types of calculations. Also, if you want to do any type of time calculations like sales amount for last year, sales amount or your year-to-date quantity, or my year-to-date or my last year-to-date, so that way we can see are our sales growing this year compared to last year, are they actually increasing? Unit price, those types of measures are going to be measures that you want to handle in the report in the data access tool or SSAS. Also, if you have any type of KPI metrics that you use, kind of the red light, green light, yellow light type of indicators, that's something that's better handled in SSAS. And so when you're planning your data warehouse, and if SSAS is in the picture, you want to keep in mind that a lot of measures can be better handled with SSAS. Those measures that are non-additive, like ratios, or KPIs or time calculations, those are better to be handled with SSAS than in your data warehouse. If SSAS is not in the picture, then you're going to have to jump through a lot of hoops to build in some of these dynamic type time calculations that SSAS can spit out in no time. Also, at this point, it's also good to begin estimating how many numbers, what's the number of rows that are going to be in this fact table, right? And so it may be a small fact table. You may have, you may determine that, we're only going to have 300,000 rows in this fact table. So that's not very big, right? That's not a lot of data. And so maybe, a clever partitioning scheme isn't appropriate in that scenario. But if you're a big company like Amazon, I can't even imagine how many transactions a day Amazon has, or Walmart, something like that. You're going to have a ton of data in here. And so you want to start thinking about, okay, what's my partitioning scheme going to look like, right? Can we partition this table down at a, if you're big like Walmart, you may even partition down at the hourly level so that, you may have 50 million transactions at an hour if you're a company like Walmart. And if you're going to be partitioning your table, your table in your data warehouse, you can align those partitions with partitions in the measure group in your cube, and that will give you a performance bonus. So aligning your SSAS partitions with your table, your SQL Server table partitions, will also give you a performance improvement there. Okay, and so at that point, we've identified the dimensions, the measures, and so we've got a very basic star schema here that we're ready to start kind of playing with and massaging and developing and moving on from here. So, Mitch, did you want to say something?
No, but we do have a lot of questions.
Okay, so we'll get to the questions here in a few minutes here. So what I want to kind of do now is I just want to kind of recap really quickly. And I want to make sure that we have plenty of time for the questions. So we've got about 10 minutes left in the session here. All right. So let's recap real quick. So the 4 basic steps to designing your star schema are: identify the business process. We want to, and when we say business process, we're specifically talking about business process, not business department. We want to identify the grain. What does one row in the fact table represent? we want to identify the dimensions. And if we get to this step and we decide, oh, we need a dimension that isn't represented by our grain statement, we need to go back to step 2 here and talk about the grain. And then if we make a change to the grain, then we'll come back to step 3, choose the dimensions and the attributes, and continue development from there. And then we want to go to step 4, which is choose the measures that we want to represent in our fact table. Now, I've been consulting for 8 years here at Pragmatic Works, so I've done a lot of data warehouse design, I've done a lot of cube design, done a lot of ETL development, and one of the things we do at Pragmatic Works is we do what's called kind of a quick start. If you're not familiar with that, is we go and we design a POC. We go from 0 to cube in about a week. So we design the data warehouse, we do ETL, we do cube, and we do reports in a week, and so it's a pretty crazy week. But I will say that this part here, designing the data warehouse, we usually spend about 3 days on. It can be 2 to 3 days depending on the kind of questions we have, and so this, and the reason we spend that much time, even though we still have ETL, cubes, and reports to do, is because this is by far the most important step, getting the data warehouse right. If you don't get the data warehouse right, you're going to have lots of problems down the road. So this is the most important step, and that's why we spend 2 to 3 days discussing that. Now, resources. If you're new to data warehouse design, these 2 resources here are killer. These are the best resources, in my opinion, that you can find. The Data Warehouse Toolkit, you'll find a lot of the material for this session came from the Data Warehouse Toolkit because it's an excellent book, written by Ralph Kimball, Margie Ross. Chances are many of you out there have read this. This is a great book, and it talks about these 4 steps, and it goes into a lot more detail than what we can do here in a 1-hour session. So I highly recommend this book, the Data Warehouse Toolkit. Also, the Star Schema, the Complete Reference, excellent book as well. Both of these books, in my opinion, should be in every professional BI person's library. They're that great. And in my opinion, the Data Warehouse Toolkit is a little more instructional, and the Star Schema is a better reference book, because if you have special scenarios that you want to research, well, how do I handle a fact dimension or a degenerate dimension or a jump dimension, those types of things, Star Schema is going to be your go-to resource for that. So I highly recommend both of these as resources for you. So look those up. I have both of these books in PDF and in paper format. Mitch does as well. So
I agree. I like the Star Schema the best if you're an intro to data warehousing. I just think it's easier to read. I think it's an easier read. It's not heavy on the technology. The Data Warehouse Toolkit, though, you will probably just read the first 5 chapters and really get everything that we talked about here and a lot more. And then the rest of that book goes department by department. So it has retail, human resources, finance, and how you would model each of those different businesses. So it's an awesome book, an incredible book. But I highly recommend both of those books.
Yeah, they're great books. And one other thing last thing I'll say about those books is that the really nice thing about those books is, for the most part, they're technology agnostic. So you don't have to know a lot about SQL Server. You don't have to know a lot about Oracle, whatever your database technology is, because they don't approach it from a technology standpoint. They're talking about it from a modeling conceptual standpoint. So that's really nice. So thank you, everybody, for attending our webinar. I hope that you learned a lot. I hope you got a lot out of this session. And if you have questions, now's the time to start asking your questions. I know we've got questions piling up now. And we've got about 500 people in this webinar, so it's going to be impossible for us to answer every single question, but we'll get to as many as possible. I put up on the screen mine and Mitch's contact information. You can email us at those email addresses. If you're a tweeter, you can tweet us there at SQL Dusty is my Twitter handle, at Mitchell SQL is Mitch's. And then there's our websites there. We blog about all kinds of different Microsoft BI related things, SQL Server scripts that we think are useful, SSIS design patterns, analysis services stuff, MDX, Power BI, all kinds of stuff there. So check out those blogs. You can ask us questions there as well. If you have a question and you can't get through on the webinar, there's the Twitter handle at PWQuestion, or I'm sorry, hashtag PWQuestion. You can use that for your and you can log on to Twitter and you can tag your question with that hashtag, and we'll go and take a look, and we're going to answer questions here in the webinar for now, but then when the webinar is over, we're going to take the remaining questions on Twitter, so check that out as well. So Mitch, do we have questions?
We have more questions than I've ever seen.
Oh my goodness.
I cannot keep up.
All right, well, we'll handle these as best we can.
Let's try this one right here.
All right.
Easy question. How did you get to the database design window? How did you get to the database
design window? So this is in SQL Server Management Studio, so that's a good question. I'll just pull that up real quick. All right, so there's my database design window. Whatever, and I went into my database. I've just got a database here set up that's called demo, and I went to my database diagrams folder and I just right-clicked and selected new database diagram. And so if you have tables that are already in your database that you want to add, you can select those here and click add, or you can just right-click and start naming new tables and creating them from scratch. So pretty simple.
All right, so another question we had was about using the surrogate key, using an integer value for the date. Why do we do that? Why would you recommend that over using the date? One person, I believe, said that they think that the Kimball book, actually the one you recommended, actually recommends using a date.
Well, the reason that we go with the integer, and I can't remember specifically why the Kimball book said to go with a date data type, but I'm going to guess here and say that it's because it's a more user-friendly value. But the surrogate keys are important in an integer type format is because they're going to perform the best, right? And they're the way that we create relationships between the dimensions and the fact tables. And remember, the whole goal of the data warehouse is high performance. And so a single field non-nullable integer key is going to perform the best. Okay, and so that's the reason we go with a date, an integer field for our date key and our date dimension. Now, I'll also mention here that this date key is a little bit different than our other, our other keys in our other dimensions, because instead of going with just an identity column where we're just going to auto increment it one at a time, we're going to go with our date dimension with what's called a smart key. And basically the format looks like it'll look like something like this, right? If you're looking at my screen, the format for January 1st, 2012, it's going to be an integer value, but it's going to be formatted to look like a year, a month, and a day. So it's still going to be user-friendly, but then at the same time, we're going to get the performance benefits of having a non-nullable single field integer key in the date dimension. So that's why we typically go with the date. Plus, if you're trying to find a record in your date dimension or in your fact table, you don't actually have to join to the date dimension to get it, because your fact table already has the date stored in the date SK, and so you can read that, and so that's kind of nice too. But that's a good question as well.
If you want to try to take one more, this one's a little tough, but there was a lot of questions around this one. It's something that Dustin will have a blog out there with a lot of these questions answered for you. But they wanted to know when you would have a dimension with a dimension. When would you break off for a snowflake? And there was a lot of questions around that.
Yeah. So and that's kind of a big hot debate topic, because some people will say, well, you might want a snowflake, right? If you want to, maybe you want it, for instance, something like product and product category, right? Maybe you want to break product category out, because we might have another fact table that doesn't relate to product, but it relates to product category. Maybe we've got a forecast fact table, right? That we don't forecast at the individual product level, we forecast at a product category level, and so we might have a forecast fact table. And so that may be a case where you'll see some people say, hey, we want to snowflake that out. Now that's fine, and you can convince me that you may want to do that, but one thing that I'll mention in regards to analysis services is that when you begin snowflaking in your data warehouse, there's going to be an impact on the design of your cube. So analysis is you have a what's called a reference dimension, right, where you use an intermediate dimension to relate that product category to our fact sales table. And so that's going to, there's some impact there with having a reference dimension, which you can find on my blog, sqldusty.wordpress.com. If you do a quick search, let's see, I've got it up here. I'll pull it up real quick. So there's my blog, sqldusty.com. So if you go to SQLdusty and you research reference dimension, there's a lot of reasons why you might consider going with a star schema, and typically you see that with people who are come from a transactional or an OLTP development side, because they tend to want to kind of normalize things a little bit, because that's what they've always done. It's kind of leaning towards that more third normal form kind of way of doing things, but you'll get better performance and you'll get better performance with your data warehouse, loading your data warehouse, and querying your data warehouse. If you try not to normalize things, if you stick with a more denormalized design, because remember, the bottom line is we want good performance, right? We're willing to sacrifice some storage. We're willing to sacrifice some redundancy, or some duplication of data rather, for better performance. That's really the end goal here, is query performance, query performance, query performance. But that's a good question as well.
All right, I think that's all we have time for today, but we're going to be doing some questions afterwards. Is that correct?
Yep. So if you have further questions, we'll take questions for about 15-20 minutes or so on Twitter. Depending on how crazy it gets, we'll try to get to all the questions on Twitter. There's the hashtag PW question. If you have further questions that we just didn't have time to get to here in the webinar, log on to Twitter, hashtag PW question. You can hashtag your question with that, and then we'll try to get to those as many as possible. But thank you so much, everybody, for coming to our webinar. We hope that you found it useful. We enjoy doing these kinds of webinars, so if you have further questions about any of this kind of stuff, log on to Twitter, check out our blogs, go to pragmaticworks.com. Lots of great resources at pragmaticworks.com, and that is where the recording will be posted on pragmaticworks.com.